Hello, hello again, gang. Mr. Cruze here with an AP Stats video for you today. An example brought to you by me. Obviously, I'm not there in person, but I do want to do an example of a 1 proportion Z interval from top to bottom, just so you see how it works and all the good stuff involved. I know you've probably seen one in the lecture video, but I want to make sure I do another one. I was going to do this one in class, but obviously I am not there. So here we go. Here's the situation. A science teacher, who will remain nameless, claims that 71% of Earth's surface is covered by water. Okay, that's the planet we live on. They claim it's 71% water. I look around. I see a lot of land. I don't know. I might be doubting it. Okay, so I'm interested in determining for we're interested in determining for ourselves the true proportion of Earth's surface that's covered by water. All right. Now, I could walk around the Earth and actually, measure things and whatever. But nobody got time for that. So we're going to take a random sample. Okay, we're going to take a random sample of places on Earth's surface. I've actually got a little thing here. This is actually on random.org. Not that. This is random.org. And you can actually find this yourself if you want. This is random geographic coordinates using Google Maps. There is a little bit of a stretching factor here, which is fine. We'll ignore that. But we're going to actually pick coordinates, and we're going to see if we hit water. So I'm going to do it 40 times. So this part of the video might be a little bit boring. If you want to skip ahead, I don't blame you. But I kind of want you to see how this works. I think I've decided in years past, if we hit Antarctica, we're calling that land actually, if I remember right. So we'll see what happens here. So here's our first coordinate. Ooh, something's wrong with Google Maps. Anyway, we appear to be in water there. So our first one is water. We will go again. Second one, this appears to be Antarctica, so we said we would call that land. Okay. And by the way, I'm documenting this as I'm looking. And I might want to zoom in just a little bit, although I'm pretty sure we're in water there. Okay. And again, this part probably not terribly exciting for you. More water. Ooh, that one might be close. I think we're still in water. Okay. All right, we're at 5. Here we go. Again, we're going for 40. More water. Man, that's a lot of water on this planet so far. When will we ever hit land? Come on. Again, I think that's still water. More water. Wow. Whew. I think the Earth's maybe 100% covered by water. That's what it's looking like. So far, 9 out of 10 have been water. Oh man, more water. More water. Ah, finally, land. There we go. Somewhere in Egypt. There we go. That's good stuff. More water. More water. Again, like I said, this part of the video not terribly exciting. I'm going to zoom out a little bit. I think we're in Antarctica, so we'll count that as land. By the way, we're up to 16, in case you're keeping track at home. I hit pick coordinates. Did it go? There we go. All right, maybe I'm zoomed out a little bit far, but I believe we'll go with it. We're saying we're in land there. And again, I could be in a lake or something, but we'll ignore that. More water. More water. We're up to 20. We're halfway there, guys. Hang in there. I'd say that's water. 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 Getting really unlucky here with this land. It's not good because I'm going to need some stuff to happen here. There we go. That is solidly land. That is more water. More water. More water. Isn't this video terribly exciting? Let's see. I think that's more water. Maybe. It's in the middle of a chain of islands. I don't know that we can zoom in any farther. I'd say that's water. That is land, for sure. More water. And I believe this is our last one. Ah, land. Nice. Let's see, 1, 2, 3, 4, 5, 6, 7. Oh, no, that's 35. I'm sorry. We still have 5 more to go. Water. Land. Water. Water. And this will be the last one. Here we go. More water. Okay. Let's see. So it looks like in our random samples, 1, 2, 3, 4, 5, 6, we had 32 water out of 40. Okay. Now, let's see. Let's go back to this. So we're going to create a one proportion z interval using that, right? So we got 32 out of 40. That is our p hat. That's our sample proportion, which is what? That's 80%, 0.8, okay? So we're going to create an interval based around 0.8. All right, now, the very first step of any confidence interval is you are going to state, all right? Remember speedo, right? That's going to be our motto here, speedo. So our first step is state. We are trying to estimate pi, the true proportion of Earth's surface covered by water, with 90% confidence. I decided 90% confidence. You can decide whatever confidence you want. I'm going to do 90%, just so it's a little bit different. But you're more than welcome to do whatever percent confidence you want. Obviously, don't do 100% confidence, because that's not going to get anybody anywhere. But that is the first step. Estimate pi, the true proportion of Earth's surface covered by water, with 90% confidence. Our second step is plan. We are going to do a one proportion z interval. Now, it is very important, especially on the AP exam. You must either name the interval by name or use the formula. I would not do both. In fact, if I were you, I would just stick with the name. We need to check the conditions, though. First, did we get a random sample? Yeah, I trust it. It was from a website called random.org. They use like noise in the air to somehow get randomness and look at random digit tables and things like that. So I trust them that the coordinates were random. Less than 10%, technically an infinite amount of points on Earth, so I think we're good on that. I don't think we have to worry about that. But sure, there's probably more than 400 points on Earth. Is it approximately normal? N times p hat. Normally it's n times pi, but we're trying to estimate pi, so I can't use pi because I don't have it, but I do have p hat. Well, there's 40, and our p hat was 0.8, which is 32. That is bigger than 10, so that is good. There is one problem, though. I only had 8 failures, which is not greater than or equal to 10. That is a problem. Now, I'm going to sidestep this a little bit. Normally we would say grumble, grumble. It should be at least 10, but I will tell you some textbooks actually use 5, so I think we're good enough to be okay here. But if this were the actual AP exam, I would grumble about it. We want it to be bigger than 10, so we are going to do what we call proceed with caution. We're going to get a result, but we're not going to run to the news and publish our results, okay? All right, step 3 is the do step, right? Again, here's the formula for a one proportion z interval. It's p hat, which in our case is 0.8, plus or minus. I need a z-score, a z-star, but we will get to that in a second. Times 0.8 times 0.2 divided by 40, all square rooted. Okay, z-star. Remember I talked about how to get a z-star. So I am going to take the inverse normal, right? Because this thing's approximately normal, of, let's see, 1 minus 0.9 divided by 2. So, and again, it'll give you a negative. Don't worry about that. We're going to go with 1.645. That'll be the z-score for a 90% confidence interval, 1.645. You may plug in the numbers and actually calculate that by hand, but I'm going to show you how to use your calculator. I think that's going to be the option most of us are going to go with. If you go to stat over to tests, you want the one prop z interval. Or I lied. It's good. One prop z interval. Somewhere there. There it is. One prop z interval is option A on my calculator. So you'll notice it actually prompts me for x and n. That's just the number of successes out of the total. So in my case, that was 32 out of 40. And as for a confidence level, we'll go with 0.9, and we are going to calculate. Okay. So my interval is 0.696. So I might write from calculator. We get 0.696 2.904. I would just go 3 places. 3 places is probably fine. So that's my interval. All right, that's all you have to do in the do step. Honestly, if you just write one proposition from calculator, that's all you really need in this step. If you want to do it by hand, that's fine. I would not do both. I would just do one or the other. And here's the important part, our overall conclusion. And these conclusions, they're going to be very cookie cutter. They're all going to sound the same, okay? And that's important. We are 90% confident that the true proportion of Earth's surface, right, the same thing we stated in our state step, that the true proportion of Earth's surface that's covered by water is between the two numbers we just found, 696, 69.6%, and 90.4%. I'm 90% confident it's somewhere between those two numbers. I don't know exactly where. The distance from 80% doesn't matter. It's not like it's more likely to be one value more so than another. It could be any number in between those two, okay? I'm 90% confident in that, all right? And that's your conclusion. Now, let's answer our science teacher's claim. Remember, they said it was 71%. Does our interval, 69.6 to 90.4, does it cast doubt on the science teacher's claim? It really doesn't. 71% is actually between that interval. So it is possible that 71% is correct. I don't have evidence to the contrary. So I can't, get them fired or anything like that. It's kind of a bummer. But that's okay. That happens sometimes in statistics. Sometimes we can't prove somebody wrong. We can never prove anybody right. I can't guarantee that the teacher's right that it's 71%, okay? Because it could be any number between 69.6 and 90.4. But I can't prove them wrong with this data. All right, that's all I have. That was just an example for you. I would like you to take the rest of class. Just begin working on the book homework. Obviously, if you get to a question that you're not sure about, ask a neighbor. And the answers will be online, so you're more than welcome to check them. But at least give them an attempt, okay? And try and use this class period productively. I will see you guys tomorrow. Have a wonderful day.